Hey class, let's talk a little bit about this, the empirical rule. So the empirical rule is a special rule that only applies to distributions that are distributed in a specific way that looks like a bell shape, essentially. What we're going to end up calling the normal distribution. Now, this bell-shaped distribution or normal distribution actually occurs quite a lot in nature, and then we'll see a little bit later that with sampling, it actually occurs quite a bit with what's what we call the central limit theorem. So it's important for us to understand some of the properties of the normal distribution. So let's first start out by drawing a distribution. So remember how a distribution works is along this axis, this is like some sort of frequency. So how often something happens. So let's say this is a frequency. And then this axis is some measurement. In this case, let's say we're going to draw the distribution of the weight of the bag of M&Ms. And let's just assume that it's normally distributed, or that it's distributed in a bell-shaped pattern. So weight of M&M bags. Right, and let's, I'm not sure what it is, but let's just call the mean, this is mu. Mu is, let's say 50 grams. 50 grams. And we'll say sigma, or the standard deviation, is 10 grams. All right, so again, what does that mean? Remember the standard deviation, that means on average, all the observations are about 10 grams away from the mean. That's intuitively what it means. That's not exactly what it means. So let's draw this. So let's put down here, we'll say 50 is our mean, and then let's just go out. Let's see, if we go one standard deviation away from 50, on this side it would be 60, right? If we go away one on this side, it would be how big? 40. Right, so that's exactly one standard deviation. A standard deviation equals 10 in this case. It could equal something else, but in my case I told you it equals 10. So that is one standard deviation away up and one standard deviation down, right? So if I go another standard deviation away, it would be 70 on this side, and over here it would be 30. And then if I go one more, it would be 80, and over here it would be 20, right? All right, so that is 1, 2, 3 standard deviations to the right, and 1, 2, 3 standard deviations to the left of the mean. So what a bell-shaped distribution really says is that most things happen around the mean, right? So remember, this is frequency. So we're going to say most things happen, right around the mean. I'm going to try my best to draw a bell-shaped distribution. There's half of it. The bell-shaped distribution is symmetric, so it looks the same on both sides. Whoa, I didn't do too great of a job, but that's okay. We know that we can draw a line straight down the middle here if I did a better job drawing it. And the mean, median, and mode would all be 50, would all be equal to the same. And if symmetric just means that if I can fold that in half, it would be the same. I didn't do such a great job. All right, so what the empirical rule then specifically says is that if I go out one standard deviation away from the mean, remember that was like right here, one standard deviation away, above and below, and then actually just sort of captured all of that data, right? All of these observations. Remember, this is, you can think of it, this is a frequency. This is how often something happens. So maybe like this is, I don't know, 1 million bags or something. 1 million bags. And then down here, this is like 500,000 or something, 0.5 million bags. Something like that, right? And then down here, this is maybe, I don't know, 100,000 bags or something. Right? So most of the bags happen between, up here in the middle. In fact, we can say exactly how many between 40 and 60. Well, if it were truly a normal distribution, we would say that that would be exactly 68%. Or roughly, yeah, I should say, it says right here, roughly about 68%. Right? But it's pretty precise, 68%. So that's pretty cool. So I'm going to change colors here. If I go out one more standard deviation, so it's 2 plus or minus 2 standard deviations away. 2 standard deviations away. So this includes really everything. Plus or minus 2 standard deviations. From 30 all the way to 70, how much is that? Well, that, I'm going to draw it up here, is says right here 95%. 95%. So that's really cool. Change colors one more time. If I go 3 standard deviations away, that's all the way from 20 to 80. 20 to 80, all of that, the whole thing. Let's see if I can scroll down just a little bit. Then that whole thing, it's going to be kind of messy to see, but that whole thing right here says right here 99.7, 98, essentially 98%, 99.7, 99.8%, yeah, 99.7%. It's 99.7%. That's exactly what it is. So the cool thing about this then is that if I know it's a normal distribution, I only need to know 2 things, the mean and standard deviation. If I have those 2 things, then we'll find out real soon that I can actually find the probability of something lying within any value, right? Anything down here on the axis. So if I pull a bag that's like 19 grams, or I pull a bag that's like 16 grams, I can say, well, what's the probability of that happening? It's actually smaller. It's less than 1%, all right? So we're going to find that kind of stuff out pretty soon. And then this empirical rule will just show up again and again and again. It helps us understand whether or not something is realistic, right? When somebody gives us some data, we can say, is that for real or is that just some kind of bizarre thing that you made up? All right, that's it for this one.